Good day, everybody. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Today, we are taking a topic in mathematics, and that particular topic is on application of ordinary differential equation, or the application of ordinary differential equation. Now, we have to solve a problem, and that exercise says, given that the population of a country doubles in 50 years, how long will it take for the population to become triple under the condition that the rate of growth of the population is directly proportional to the initial population? So it's a very simple problem, and we use the concept of a solution to the ordinary differential equation, to solve this problem. So this is how it goes. Now we are given this condition. Let the population number be n. Let n be the number of the population. So let n be the number of population, and let the t be the time. So the rate of change with respect to time is going to be the n dt, and then we are told it's proportional to the initial population, which is the number of the population. So what we need to do now is to remove this proportionality sign. So what we have here now actually means the n dt is equal to kn, where k is proportionality constant, a is proportionality constant. So it's proportionality constant. That's our k constant. So what we need to do is to use the idea of a separable variable method to solve this problem. What I mean by separable variable method is that we take all the same variable to one side of the equation and the other variable to the other side of the equation. So what I'm going to have now is to take the n to under the n. So I have the n divided by n, then you cross multiply the t to the other side. So it's going to be k dt. So the next thing is to integrate both sides of the equation. If I integrate from the standard integral, the n over n means the length of n. So integration of dt, because k is a constant, we can write it outside the integral formula. So integration of dt actually means c. So what we have here now will be kt. So that means length n is going to end up in kt. So we move down to the next line of our solution. So we ended the other line as length n is equal to kt. Then I said we integrate it. So the limit of integration for the number of population is going to be, I've already integrated. So I have a length n is equal to kt. So the limit of our integration for the number of population is from the initial population n, and the population n double to 2n. So is equal to k, then the time t normally starts from 0 up to 50 years. This particular expression we have here, we use it to derive the value for the constant k of the proportionality. So from the law of logarithm, this particular expression I have here actually means we substitute 2n and n there. So we are going to have length 2n take away length n. That's the meaning of this expression. Then what I have here, the meaning means k times, we substitute 50 and 0. It's going to be 50 take away 0. So which is going to be 50k. So according to law of logarithm, subtraction or logarithm means we divide whatever we have there. So it's going to be ln 2n divided by n. N cancel n, that will give us ln 2. So ln 2 now will be equated to this 50k that we have here. Take note of that. So now from ln 2 is equal to 50k, then we divide both sides by 50. So k will now be ln 2 divided by 50. So the constant of proportionality is now 0.0138625. Having gotten that, we now move down to the next line of the question, that if the population triple, that means we are going to use this standard integral formula, that is ln. Our limit of integration, the integration that we had here the other time is ln n. Ln n is equal to kt. So in the next line of question, the population still starts from the initial, and we are told that the population, what will be the time when this particular initial population n triple, that's going to be 3n. Then the time still click from 0 to t. So when we substitute these limits inside the bracket, it's going to be ln 3n take away ln n. According to law of logarithm, it means ln 3n divided by n, which is ln 3. So this ln 3 will be equal to, when we substitute this t and 0 here, will be equal to k bracket t minus 0. So we have gotten our k to be this value, 0.00138. So we substitute. Therefore, ln 3 is equal to 0.0138625 times t, because here t minus 0 is t. So to get our t now, we divide both sides by 0.0138625. So we have ln 3 divided by 0.0138625 is equal to the time when the population triple. So when we divide, we are going to have the value of 79.25 is equal to t. So therefore, the population triple in the year when the time is 79.25 years. So this is an aspect of ordinary differential equation in real life application. In this particular problem, we use the concept of the method of a separable variable. Thank you. Please do not forget to share, like, subscribe, and click on the notification button to have more of my video. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Thank you for having you. Have a nice day. Bye bye.